Cool. Now we're live. Hi everyone. I just said this, so I'm going to go quick. But if this is your first webinar of us, welcome. Today we're going to be talking about Databricks and feature stores, essentially how to do proper MLOps on Databricks. I'm going to show the Databricks feature store, show feature form. I'm going to talk about a lot about the problems that these things solve, as well as kind of getting into more of one, the theoretical, two, the like, I'm going to give a demo, I'm going to show code, I'm going to walk through stuff like that. And then finally, I'm going to talk a bit about performance, talk a bit about Delta and Iceberg, talk a lot about kind of more the data engineering part of MLOps. If you have any questions, you can leave them in chat and Q&A if you're on Zoom, or just leave a comment on LinkedIn and I'll make sure to look at those. Fantastic. Let's get started. I'm gonna run some code in the background while we're going, just because it takes a little bit to run. So I want to make sure it's ready for when we get to the code part. Okay, that should be good. Someone asked, is this a beginner-friendly session? I think there are parts of this that will be really beginner-friendly. There are parts of this that won't be, but the beginning is going to be pretty general about the problem space. So I think it's a good session for you. Okay, let me share my screen. If I can figure out how to do that. Oh, Marie, I think you need to make me host again.
I believe you are host.
Okay. There it is. It doesn't show when I'm in a smaller view, which is very annoying. Let me get the right place. Okay. There we go. Great. You all should be able to see this. Can you see the slide, Marie?
I can.
Okay, great. All right. Let's talk about feature stores. So for those of you who maybe have used feature stores before, maybe you've used the Databricks feature store, maybe you've used another one, maybe you've never used one before, but you just heard the term. Even if this is your first time hearing the term, a lot of people, when they hear feature store, they have this perception that it is a database where you store features, which kind of makes sense given the name. And to a certain extent, you'd be right. A lot of feature stores that exist, including the one on Databricks, this is what it is. It provides you a place to, after you've built your features, to kind of dump the tables into a feature store. And that feature store, what it's used for, features are just inputs to models. It's just data that goes into your model for training. And if you're doing like fraud detection or something online, where the model's always running and needs low latency inference, it also runs there too. So you have your training and your inference pipelines that feed out of the feature store. And then on the other end of the feature store, you build your features and put them there. That's kind of what a lot of people see. And again, for Databricks, you'd be right. I actually want to quickly walk you through what the Databricks feature store looks like. So in the Databricks feature store, you go to features, you'll see all these tables. Each of these are feature tables. These feature tables can be served for training and for inference. So this is just a list of all your features. You'll see the features that exist in each feature table. And if you click on the feature table, if you click on the feature table, you can, I guess, see the feature. Just like the very, very, very basic amount of information about the feature, but technically this is the feature. Great. So that's what the Databricks feature store and a lot of feature stores look like. Now, having worked with a lot of companies that have feature stores that have problems that feature stores solve, I have many, many times seen a similar pain point, which is that feature stores, as they're typically designed, don't store the transformations. What I mean is, it is your job to build a feature and put it into the table. If that feature changes, like if any of the pipeline changes, you have to go and update the table yourself or create a new table. And you also can't really get proper lineage. Like you don't know what the feature is, like I showed you. You just have that column, right? And that's all you get. So you can't see what that column really is and how it's defined. We thought that was wrong. We kind of really rethought the feature store concept. Our view, and we call it the virtual feature store, is that feature store should not store just the data of the feature, but rather a feature store should be storing the code that makes up the feature. So to make this more explicit, if you go into like, oh, I don't have this in, or I guess it's still there. If you go into one of our data sets on feature form, like this one, you can see the code that makes up the feature. You can see the training sets that this feature goes into. You can really see all of the lineage as opposed to what you see today in like the Databricks feature store, where if I look at that same feature in Databricks, this is all I get. So the reason this is possible is because we tie together the feature to the code. So you define your features as code. As the code changes, the features change, and feature form actually computes the feature for you. So all the scheduling, the stream processing, etc., kind of happens there. Now, let me get into why that's important and why it's different. We call the idea of feature lakehouse. And I want to quickly talk about what this enables and what problems we've seen many, many companies face that this solves for. So one of the problems we see all the time, probably the most important problem, is facilitating the deployment of features. When you're working in machine learning and you're kind of coming up with your features, experimenting, etc., you are often working in a notebook. You're probably working in like Pandas or DuckDB or whatever. And it's very quick. It's very like science based. Like you're trying stuff, you're throwing stuff away, you're changing things. It has a very try and throw away type nature to it. And then once your features are ready for production, you have to put them in prod. When you put them in prod, you suddenly have to worry about performance. You have to worry about perhaps stream processing. You have to worry about batch features, maybe incremental updates. You start worrying about on-demand features, like features where you have to actually build them at request time. You start worrying about latency, start worrying about freshness of your data. All these concepts that just didn't exist in experimentation when you actually built the model and trained it suddenly become extremely important here. And most of the time, at most companies, all the code that you built for experimentation is not production grade. So you have to essentially rebuild it into this paradigm. And then if you start thinking about stream processing, you start having to worry about backfill. Like I have this event that's happening in this Kafka stream. My feature is an aggregate of the last 30 days. How do I backfill the last 30 days into my processing so that I can start getting features out? So there's this like chasm between production and experimentation. That's pretty major. And we've seen with like if you use like a typical feature store, like the Databricks feature store or Feast or something, it doesn't really help much because you'll still have to build all your features. You have to build that feature pipeline and then just write them to the feature store. We think that the way to solve this correctly is the feature transformations have to inherently be part of the feature. And we've seen that if you do this correctly and you define your features as code, this chasm kind of closes. It becomes much easier to get your features from experimentation to production. Because how many times have you kind of seen this sort of thing happen where you have your perfect features in your notebook and it's hard to get them in prod? The way we see companies solve this today, obviously companies are getting their features in production, so it's happening. What we have seen of companies that we've come into, of companies we've spoken with, that one of two things happens. Either the data scientists themselves have to go and actually build these feature pipelines from scratch. And so then they not only have to be amazing data scientists, but they also have to be amazing data engineers. Or the data scientist passes their notebook to another team, and the other team is tasked with getting that into production. And now you suddenly have two teams required. The data scientists are dependent on another team. The data eng or ML team is usually completely overloaded with things they need to do. And there's there's a lot of room for error because you kind of have added another pretty major layer of abstraction between your features being built and in production. So I'm going to take a second and show you what that looks like, or what that could look like with something like feature form. So again, in Databricks, you'd probably set up a job, you'd kind of work within the Databricks ecosystem to try to build those features. And then you would write them to one of these feature tables that I showed you. And then in the feature tables, you would see the features exist. Let's compare that for a minute to feature form. So feature form, you would grab we call them providers. So you grab things like your Spark or your Dynamo or your Snowflake or whatever you're using to process features, you go and grab them. You can start registering things. For example, you can register like a table in Snowflake or a CSV. So here's what I'm gonna do first. I'm gonna register a CSV. You can register a table in BigQuery. You can kind of register all your primary data is what we call them. And then we can get into the more interesting bit where we actually start building off of that thing. Like here, what I'm doing is I'm defining my first transformation on that CSV. I can start applying this stuff. I'm going to go to a more interesting one. So example here, I have percent balance. Percent balance, I'm going to take off this, is defined as a transformation, the data frame transformation that runs on Databricks. It takes an input, which happens to be that CSV, which is already done processing. Or it takes, sorry, the first transformation, which cleans up the CSV. And what it does is it creates a new column where it's called balance percent. And you divide for each transaction in this data set, which you can see here. This is the data set. It's a list of transactions. For each transaction, it divides the transaction amount by the balance. So you can see customer account balance, you can see transaction amount. I want to divide this by this to get what percentage of the user's balance this transaction makes up. There is an edge case where the customer has a balance of 0. In that situation, you kind of want to just set something because you can't divide by 0. So I just put it as, here, I'll put it as 100. Okay, so I'm gonna run this. And then I'm gonna apply it. When this applies, again, it runs on Databricks. Like if I go to my Databricks job runs here, you can actually see it running. So feature form will get this thing, it will store it, it'll be visible. So if I open the UI or this local UI I'm doing, oops. Let me open my local UI. You can see that all these features and data sets begin to exist. Like I can see percent balance, I can see the code that it generates with it, I can see all this stuff as compared to Databricks where you wouldn't really see that. Like if I hit customer account balance, or sorry, balance percent, which is the same thing, you don't really get any of that information. So that's the big difference, and that's what we define as features as code, which we've seen create a huge difference. So now data scientists don't have to worry about building scheduled jobs in Databricks, setting up proper monitoring, doing all the things that, again, the data engineer is totally capable of doing. Incremental pipelines, stream processing, etc. But for a data scientist, that's a whole different skill set. And it's a pretty big one. Like if you work with data engineers, you know that becoming a really good data engineer takes a lot of work and some talent in data engineering. And I don't think it's really feasible to have every good data scientist, also be an amazing data engineer. And so with Feature Form, we kind of handle both for you, which is really nice. I'm going to run through a few more cells again, just so this can happen while I'm speaking. Okay. So another problem we see a lot, a feature stores kind of solve, is enhancing collaboration and organizing experimentation. People don't document their features. And when they do, they don't keep them up to date and maintain their documentation. If you are at a very unique company where that's not true, congratulations, but in 99% of companies, it's just not the case. People just don't document their feature pipelines. So you have these feature tables and features in them, and you have all these jobs running, and it's not even clear what jobs are for which feature. How it looks like is you end up with features in prod that are based off of code in untitled notebooks, or just notebooks that are kind of in Slack or somewhere. Those notebooks aren't super properly like documented. Like do you have final, some random cleanup code. You start putting things in your online and offline stores. You end up with like feature table v7 in your Databricks. You end up with shell scripts getting run that do ad hoc jobs on Databricks that create your features. And then to top all of this off, there's no documentation of what to do in what order and how it all works. So it's chaotic to say the least. And that's another thing that this features as code paradigm that we have really helps. Because if you look at, so this thing all ran already in that minute, but if I go back to that feature I ran earlier, right? And I run it again, just the percent balance, you'll see it happened instantly this time. The reason it happened instantly is feature form was going to create a new one, but then it saw that one already existed. So it uses the one that already exists. The way you can do that is we have this idea of equivalence, where because the code in here is the same as the code in the other one, it's going to use the one that already exists. So they're equivalent. This PyDoc in this code gets passed along with the metadata. If this changes, if I change this PyDoc, it doesn't actually change the equivalence. So it will still be equivalent. And in the dashboard, if I look at percent balance, I could see all the versions that exist. I can see all this stuff. In fact, if I was to come here and change this to 75 and run this again, it's going to run again because I changed it, and there'll be a new version. If I go back to the UI, and I'm gonna, I guess I was already there. Well, you can see now that the newest one is running. If I go into the one that's running, you can see the two different versions. You can see one's red, you can see one's running. You see, when I clicked on, I went to the newest one where it's 75. If I go to the old one, it's 100. So I can see all the different versions that exist. I can see the features based on these different versions. All this happens automatically. So documentation just is a part of your code and a part of the feature store inherently, as opposed to, again, in Databricks where you would actually have to manually go and edit this description yourself, and set all this stuff and try to accomplish something similar to what feature form is doing. So documentation comes in, you get the versioning, you get all this stuff. the notebooks and things, like all that code is getting shipped into this centralized metadata store, like feature store of code. And all of that gets run for you. So there's no ad hoc scripts and things, like feature form is handling the updates, the runs, the incremental pipelines, the streaming pipelines, etc. It also helps increase reliability. Feature form has built-in monitoring. So as those features are changing and as you're serving them, you can actually monitor the change. And so you can have feature form warn you if something has changed dramatically. This is only in enterprise, so I'm not demoing it today, but I do want to demo something similar, which is actually serving features. So I've created all these features and these feature pipelines. I'm now gonna grab, so the whole point of a feature store, right, in the end, is to train models and to serve features to that model. So here what I do is I grab my training set called TS. TS I defined here when I registered a training set called fraud that had the label is fraud and the features A and B, average transaction percent. I applied it and it created them. In the UI, you can again see those features. Average transaction percent, you could go through the lineage again, you can kind of do all that stuff. Now, I'm gonna grab TS. I'm gonna turn it into a data frame, which everything in feature form can be converted to and from a data frame. And then I'm gonna train a really simple model on it. The thing I'm doing here, which is optional, but it can be very valuable, is I'm setting the model string. It's a string, like literally it's right here. That string gets associated with the training set. So I'm going to show you how this looks like. So I'm going to train a model here. So we are training. I think it will take a sec. I grab the training set. You can see the training set here. These are just deprecation warnings because one of our libraries is using something deprecated. And this is a dependency of feature form that we have a ticket out for. So you can see the training set. You can see the columns. So these are the two feature columns. This is the label. Is this fraud? And then you can see there's 10,000 rows. It's 3 columns. And then the accuracy is 100% because this is a made up training set, but you can kind of get the sense of how it works. So now I have this trained model, RF. I could deploy this model, and the deploying of the model is outside of feature form's domain. You can deploy the model. And then when you want to serve to that model, right, I can get my features. So here I'm going to get 2 features. And then I'm going to predict, make a prediction, rf.predict. Yeah. So I get 2 features. And then here I actually don't want to hardcode this. I want to do user average transaction. So I have user average transaction percent. I want it for user C533 whatever. I get the features and then I make a prediction based on those features. Predict, I wrote that part wrong. This needs to be, it's a list. So RF predict takes a list of features, not just a single feature. So now it works. So you can see that I got the 2 features for this user. The values are 773 whatever and 0.08. So this was 8% of their balance on this transaction, and their average transaction is $773 and some cents. And the model that I trained predicts that it's not fraud. If I go back to the UI and I go to models, I can see that that model exists now. And if I click on the model, I can see the training set there. And I could see, I don't know why the features didn't show up, but I might have, I didn't add the features to the code. That's why. So if I add that same model here, then it will associate. So now if I go back to that model, and I'll refresh it just to give it a chance, you can see the features that this model used, and you can see the training set that this model uses as well. And you can, again, go through the training set. Okay, this training set made up of these features. I can see the task runs. So task runs are tasks that feature form ran. And in this case, this run is actually a Databricks job. So you could actually go into here and find the training set job. It's this one. So you can see the training set. You can see anything, any metrics you'd need in Databricks here as well. So all this comes together to give you proper lineage and monitoring, because I know what the model's getting served. I can tell how those features change. I can tell what the model is trained on. I can do a diff of those two things and understand if there is monitoring happening, or sorry, if there is drift happening. And then finally, preserving compliance, governance, users, access control, all that stuff happens in feature form. One thing that's really valuable here that feature form does compared to something like Databricks, just to think through, is the Databricks governance feature works on the table level. So each feature table you can set proper governance on, but it doesn't work on the feature level. So you can't specify, hey, this feature can only be used by these models. The other thing with the Databricks feature store you'll find is you can't share a feature in two different feature tables. In feature form, you can, because we have the idea of individual features. In Databricks, you'd have to copy that feature because it doesn't store the code, it just stores the table. So you'd have to copy the feature into each table. Okay, let's talk a bit about performance and everything. So feature form is built to run on any data infra that you need. So we run on Databricks. We actually have a lot of users and a lot of work done on the Databricks ecosystem. So we work with Databricks. We work with Snowflake, we work with ClickHouse, we work with BigQuery, and many others. In Databricks and Spark, we also support, S3, GCS, Azure Blob, etc. This was kind of originally how we built feature form. We actually built different implementations for each one. Some problems that we had on performance that we've since resolved, is each provider, like Databricks and EMR, are different. So we had specialized implementations for each. And because they're so different, the optimizations we would perform would be different. And there was some stuff that we could do generically, like we knew this makes EMR faster, this makes Databricks faster. But in practice, a lot of that got pushed up to the data scientists. And it ended up with relatively slow processing because we didn't have proper schemas on the Spark side and directories and all these other things. We moved feature form to everything in feature form now reads and writes Iceberg. And Iceberg in the Databricks ecosystem has kind of become a first-class citizen. So all this stuff will just natively naturally fit into the Unity catalog. It will work side by side with Delta, etc. For those who don't know, the details of why Delta and Iceberg, this actually is relevant to both of them. They are very different. I'm not going to get too deep into differences, but everything I'm sharing is true for both Iceberg and Delta. So the way they work is that there will be a entry in the catalog. So in Databricks ecosystem, in the Unity catalog, there's an entry for the table. That table actually points to a metadata file. That metadata file points to kind of a set of lists, which if you follow them down, eventually go to your data layer. And those data files are, by default, Parquet files. What this allows for is a few things. One, you can set up indices. So with an index, what that allows you to do is you can specify, hey, this column is an index. And what it will do is it will put columns that are close together, like users A through C will be in one manifest file, and D through F will be in another manifest file. And it will actually, you can partition, you can sort, you can do all these different things. And all that metadata will be stored in the manifest, which kind of allows us to build indices for feature stores in a way that is agnostic to all the different providers, which is really powerful. The other thing it gives us, which is also very powerful, is you can see at the top here, there's two metadata files. Metadata file 1 has S0, one manifest list. Metadata file 2 has S0, S1. Every time a table changes in Iceberg or Delta, rather than building the whole table all over again, it builds a delta. It puts that delta into a manifest list. and then it appends that manifest list to the metadata file. So the metadata file is this metadata file is actually a snapshot of what the table looked like at this time. And when it changed, it creates a new snapshot. And it's not copying all the data, it's just kind of tracking all the deltas to apply to get to that point. So what did this enable of us? All of our providers now read Iceberg, read and write Iceberg. So we're able to, one, because of snapshots and incremental changes, stream processing became highly efficient and generic. Our ability to materialize into Dynamo, we can materialize just new things, new deltas, which is very powerful. We do things like merge on read, which means that for a lot of features, especially when you're building them, you write way more than you transform. So you're writing constantly. So rather than keeping the table constantly changed and up to date, we just write all the deltas, very typically kind of small deltas. And then when we process the feature, we kind of squeeze them all together. And it ends up being highly more efficient. And then finally, we'll push down predicates. If I do a query, such as give me a query where users are between A and B, in a typical Spark job, what it will have to do is it will read everything, all the Parquet files, and then it will sort them or partition them or something, whatever it decides, and then it will just drop all data that doesn't start with A or B. With Iceberg, because we put the index in the Iceberg table directly, it won't even read the data that doesn't start with A or B because it knows what files contain data that start with A and B. So it allows our compute providers to skip unnecessary data. For joins, which are for building like training sets and all of these things are extremely powerful for joins. For joins, because we use Iceberg, we sort because in the Spark there'll be like, let's say 100 nodes running. So what typically will happen is if you're joining, each node will read a couple of files from one table, a couple of files from another table. It will shuffle them around so that files pertaining to the same data or same rows, same users, let's say, if we're joining on user, will end up on the same node. That's what it has to do. So it does this massive shuffle operation where it passes everything all over the place. Very expensive. And then it does the join. With Iceberg, if I set up my indices properly, again, I know that for this table, users A for C are in these files and A for C are in these files in this table. So I don't have to shuffle as much. I can either grab both of those directly into one node or grab them into like 3 nodes and then just have those 3 nodes shuffle rather than having all 100 nodes have to shuffle. It also unified streaming and batch because of those deltas. We can make a stream and a batch processing pipeline look the same from our perspective, which is just extremely powerful for us. And the nice thing about feature form, getting back to like that first section about deployment, is you don't have to understand how to fully utilize Iceberg. You don't have to know all the details of Spark. As a data scientist, all you have to do is define your SQL, your PySpark code, define it in feature form, and let feature form handle the details of putting it in production. So it unlocks data engineering to the data scientist so that they can do it themselves. And for the data engineers, underneath the hood, we're doing all the stuff you'd expect. So we end up with high quality production grade pipelines that you can tune. Every single Iceberg parameter, every Spark parameter, everything is available to you in feature form. So you can perfectly tune these things for yourself. If you do this right, it will solve the problem that we see over and over again, which is that most machine learning is just data engineering, just getting your data in the proper form. And with feature form, that data engineering is democratized to the data scientists themselves so that they can work and be productive and get better models in production faster. Awesome. Well, I hope that was valuable. That's kind of all I have for today, but I want to open it up to questions. If you have any questions on Zoom, feel free to throw them in the Q&A. And then if you would rather ask on LinkedIn if you're on the LinkedIn side or somewhere else. Leave a comment there, and Maria will be monitoring that as well. Cool. I'll give it a minute, see if any questions come in. Marie, maybe you could, while maybe people are writing up their questions, you could take a minute to talk through what happens now.
Sure. Thank you so much, everyone, for coming to this webinar. I hope you guys found it insightful. After this webinar, I will send you guys a follow-up email. It'll have a recording of the webinar, so you can look back at it if you want to. Also, there'll be links to our Slack community, links to our docs, and our open source, if you're interested in trying us out. Simba, it looks like you do have a question.
Yeah. So the question is feature form basically replacing the need of data engineers to deploy a feature in production? Yeah, I think generally yes, but just to be very clear, I'm gonna go back to a couple slides. So data scientists work in notebooks. They need to get it into production. So it's someone's job to get this notebook, which is like kind of experimentation code and pandas, and rewrite it into proper Databricks jobs and have proper monitoring and manage and maintain those features in production. Someone has to do that. Otherwise, you end up in a situation where you have these perfect features and they don't make it to production. One way we've seen that solved, a very common way, is for data scientists to pass it to data engineers, for the data engineers to get it into production. So not everyone does that, but for the ones that do that, yes, this would replace the need to do that. We believe that the data scientists should be enabled to deploy their own features into production. But with current tooling, like if you just give them raw Databricks and say, hey, build production grade pipelines, it's not going to happen, or you're going to end up with a lot of outages. So yeah, feature form kind of fills the gap so that a data scientist themselves can feel comfortable taking their kind of experimentation code in notebooks and converting that into production code, and allow feature form to make that code into a production grade feature pipeline. Thanks for the question. That's a good question. Cool. Any questions on LinkedIn, Marie?
None on LinkedIn.
Okay. Oh, a few more. Okay. So can you, okay, two questions. One I'm gonna answer first, which is how does our pricing work? So Featureform is open source. I wanna open to that. For the pricing, we have an enterprise solution. Enterprise solution comes with support. It has the monitoring stuff. Some of the stream processing stuff that I talked about is only in enterprise. Governance, access control, users, and also integrations, like custom integrations. All that comes with enterprise. Today, how we price is it's a bit dependent on customer. I would say most of our customers deploy on-prem, so in their cloud, and we charge them just a license fee. So we just do a flat fee per year or something based on number of features being served. But yeah, if you're interested to learn more, we do it kind of based on the problem. My goal has always been to get this into as many enterprise places as possible, make sure those customers are super happy, and make sure the pricing is fair. I'm less worried about, squeezing every dollar out, which maybe you've experienced with other, like Databricks and stuff can get very expensive very quickly. We're just in startup mode where we just want to make sure you're happy and getting proper value. So yeah, reach out. I'm simba@featureform.com if you want a more personalized answer. Okay, quick recap. Can you give us a quick roadmap for MLOps and a quick recap of the session? Yeah, so for MLOps, I think there are four main problems to solve. One is just data. Most of what data scientists do, especially in like fraud, recommender systems, a lot of places, is just data engineering. There's also experiment tracking, with things like ML flow, which is like, okay, now I have my data. I need to, track experiments, feature serving models. So after my model is trained, how do I get it to production? And then finally, monitoring and evaluation, making sure my model is doing well in production. What feature form does is it makes the data part way better. So what we make it possible for data scientists to do is build their own feature pipelines, get them into production, have proper versioning. The problems we solve are actually in this slide here. So facilitate deployment, make it easier for data science to deploy their own features, enhance collaboration, increase reliability, preserve compliance. And with feature form, all the code, all the data lives in your infrastructure. So for Databricks users, for example, even though they're using feature form to define their features as code, the transformations are still running on Databricks. And they're being stored as Iceberg or Delta tables, and it's all very like native to Databricks, even though the data scientists don't have to know all of everything that a data engineer would have to know. So I hope that was a good recap or TLDR. Great. That was a good handful of questions. Maybe one last glance on LinkedIn.
I think that's it.
Okay, last chance. Stop sharing my screen, and then if I don't see a question, you can always email me if you have other questions. You can also join our feature form community and ask there. But thanks for spending some time with us this morning or afternoon or evening, wherever you are. And yeah, hope this was valuable to you all.